welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start discussing about the physics, and that is your class 32th, where we had completed 31st class in the last session, where we had completed unit 1, which is physical world, unit 2, units and measurement, unit 3, which is motion in a straight line, unit 4, that is your motion in a plane. Now we're going to continue with the same, and we'll be going to end up with soon as well. So in motion in a plane, that there is something which has been left here, and so for that we'll be having to cover up, and we have to cover up that soon as well. So we discuss about the physical quantity and a symbol, dimensions, units, and remarks about it. So yes, we go for the same. So the first we have physical quantity. Then we have your symbol, then of course dimension, unit, and remark. So for that, here we go for the first quantity, physical quantity, that is your position vector. Then another quantity we have for the displacement. For position vector, the symbol is R, dimension is length, unit is meter, and the remark is vector. It may be denoted by any another symbol as well too. So with the same for the displacement that we have, displacement symbol is delta R, length is, dimension is length, unit is as well meter, and this is the 2 vector. Next, for another one which we talk about for the velocity. Velocity being divided into 2, which is first is your average, the second is your instantaneous. So just go for marking. So in the same way we go for it, and that's what we'll discuss about it. So here we go for instantaneous velocity, that we had talk about it, and for the same it will be, we got a margin. Then we'll talk about, for after that velocity, we discuss about the acceleration, which is first we'll discuss about the average. So on the same way we go for it, and that is your for average, and then we go for instantaneous. So for acceleration, after that we'll go for the projectile motion. We go for projectile motion. In terms of projectile motion, first we go for time of maximum height. maximum height, horizontal range, now we discuss about the circular motion, the lastly. For circular motion, that is angular speed, the another is centripetal acceleration. So now on the same behalf of it we discuss here. Now we go for the velocity, that we'll discuss down. So the dimensions is LT minus 1, that is LT inverse, meter second inverse. Average velocity, it will be, the symbol is V bar, and where this is dimensions in the unit. The mark is dr by dt, which is your vector. And for instantaneous it is V, and that is your dr by dt, that is vector. For acceleration, it is LT inverse square. The unit is meter second inverse square. Now for average, the symbol is A bar, and the units and the dimensions is this. It is delta V by delta t, which is vector. For instantaneous, it is A dV by dt, which is vector. For projectile motion, time of height is Tm, symbol is, dimensions is your T, symbol unit is your S, and remark is V naught sine theta naught by d. For maximum height, it is Hm. The unit is, the symbol is L, dimensions is L, unit is M, and remark is V naught sine theta naught whole square by 2g. Another it is your R, this is L, unit is M, V naught square sine 2 theta upon g. For the circular motion, it will be angular speed is omega, the dimension is t inverse 1, this is read by second, d theta by dt equals to v by r. Centripetal acceleration, it is your A, which is LT inverse square, meter second inverse square, equals to V square by R. So for that we'll discuss here further. Another question we have here is your, in a harbor, wind is blowing at a speed of 72 km per hour, and the flag on the mast of the boat anchored in the harbor flutters along with the northeast direction. If the boat starts moving at the speed of 51 km per hour to the north, what is the direction of a flag on the mast and that is the mast of the boat here. Another question is that the ceiling of a long hall is 25-meter high. What is the maximum horizontal diameters that a ball thrown with a speed of 40 meters second inverse that can go without hitting the ceiling of the hall? Another question, a cricketer can throw a ball to a maximum horizontal distance of 100 meter, where how much high above the ground that can be cricketer thrown the same ball? Next question, a stone tied to the end of the string 80 centimeter long is whirled in a horizontal circle with a constant speed. If the stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of acceleration of the stone? Then other we have an aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 km per hour. Compare its centripetal acceleration with the acceleration due to gravity. Another is, read each statement below carefully and state with the reasons it is true or false. The first statement we have that the net acceleration of a particle in circular motion is always along the radius of the circle towards the center. Another is, the velocity vector of a particle at a point is always along the tangent to the path of the particles at that point. Another is that acceleration vector of a particle in uniform circular motion averaged over one cycle is a null vector. Another is, the positions of a particle is to be given as r equals to 3 t I cap minus 2 t square j cap plus 4 k cap meter, where t is the second and the coordinates coefficient have a proper units for x to be in the meters. Find the v and a of a particle. What is the magnitude and direction of the velocity of the particle at t equals to 2 seconds? Next is, a particle starts from the origin at t equals to 0 second with a velocity of 10 j cap meters per second and moves in xy plane with a constant acceleration of 8 I cap plus 2 j cap meter second square, where at what time is the x coordinate of the particle is 16 meter. What is the y coordinate of the particle at that time? What is the speed of the particle at that time? The another question is, I cap and j cap are the unit vector along x and y axis respectively. What is the magnitude and the directions of the vector I cap plus j cap and I cap minus j cap? What are the components of a vector and a direction of a vector? That I cap here that has been 2I cap plus 3j along the directions of I plus j and I minus j. You may use a graphical method as well. So now on the same way, for any arbitrary motions we have a space as well. We read the statement below carefully and state the reasons with the example if it is true or false. A scalar quantity is one that is conserved in a process, can never take negative values, must be dimensionless, does not vary from one point to another in a space, and has the same value for observed with a different orientation of axis. Another is, an aircraft is flying at a height of 3400 meter above the ground, and if the single subtended at the ground observations point at the aircraft position 10 seconds apart is 30 degree, what is the speed of the aircraft? Next is, we have the next few questions that we have as the last one, so deal with it, and that is your additional exercise question. The question is, in a vector has a magnitude and direction, does it have any location in the space, and that can it vary with a time with two equal vector a and b at a different location in the space necessity and necessary that have identical physical effects. Give examples in support of your answer. The another we have here, a vector has both magnitude and directions. Does it mean that anything that has a magnitude and direction is necessary a vector? And the rotation of a body that can be specified by the direction of the axis of rotation and the angle of rotation about the axis, and does that make any rotation a vector? Another is, can you associate vector with the length of the wire that bend into the loop and a plane area as a sphere and explain. Next question is, a bullet fired at an angle of 30 degree with an horizontal hits in the ground 3 kilometer away. By adjusting its an angle of projection, that can one hope to hit the target 5 kilometer away. Assume the muzzle speed to be fixed and neglect air resistance. So the question is, the fighter plane flying horizontal at an altitude of 1.5 kilometer with a speed of 720 kilometer per hour that passes directly overhead and anti-aircraft gun at what angle from the vertical that should a gun be fired for the shell with muzzle speed 600 meter second inverse, and to hit the plane at what minimum altitude should the pilot fly the plane avoid being hit. Next we talk about it. The question, a cyclist is riding with a speed of 27 km per hour. As he approaches a circular turn on the road of the radius 80 meter, he applies brakes and reduces his speed in the constant rate of 0.50 meter second every second, and what is the magnitude of the direction of the net acceleration of the cyclist on the circular turn. And the question, show that for a projectile the angle between the velocity and the x-axis as a function of time is to be given, and where theta t is equal to tan inverse v0y minus gt by vox, and that shows the projectile angle theta naught for a projectile that is launched from the origin of the given, where the symbol have their own usual meaning. Now we're gonna end up here, and as I told you, there are many things that will be discussed further, which will be going to end up here only, and after that we'll be discussing the another unit, which is your, of course, the laws of motion. So that we'll discuss here, which has been the important one. So please stay tuned with us, and please like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Please keep supporting us. Other than this, we had done your reasoning, which is your verbal reasoning and the non-verbal reasoning. We had started with the quantitative aptitude as well. We had done your chemistry part 1 and chemistry part 2. We are dealing, of course, in terms of physics. Here we had done your unit 1, which is your physical world. Unit 2 is your units and measurement. Unit 3, which we had done your motion in a straight line. Unit 4, motion in a plane. Unit 5 will discuss next. Will discuss about the laws of motion. Unit 6 is your work, energy and power. Unit 7, system of particles and rotational motion, and unit 8 is your gravitation. Then after we'll be going to end up. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you. Please support us.